Imagine standing at the edge of the ocean as the day ends. Not with one sun dipping below the horizon, but two. The sky would glow longer, shadows would overlap and stretch in strange directions, and sunset itself would feel like a slow cosmic performance. As exotic as this sounds, such a world would not be unusual by galactic standards. Our single-sun solar system is actually something of an exception. Across the Milky Way, many stars are born in pairs or even larger groups, bound together by gravity in long-lasting orbital dances. The galaxy is built on pairs. When we look up at the night sky, most of the bright stars we see are not alone. Astronomers have learned that a large fraction of stellar systems, especially the more massive and luminous ones, are binaries or multiples. What appears to the naked eye as a single point of light often turns out, under closer observation, to be 2 or 3 stars locked together in motion. A famous example is Alpha Centauri, which is actually a 3-star system rather than one. This means that, statistically speaking, Earth narrowly missed being born under a double sunrise. A lost companion to our Sun? Some scientists have even proposed that our Sun may once have had a distant stellar partner during its formation. This hypothetical companion, sometimes nicknamed Nemesis, could have drifted away billions of years ago as the young solar system settled into stability. While this idea remains speculative, it highlights an important point. 2 sun systems are not rare accidents. They are a common outcome of star formation. If that second star had stayed, Earth's history from climate to biology would have unfolded along a radically different path. Not all binary stars are the same. Binary systems come in many configurations. Some stars orbit so closely that they nearly touch, sharing outer layers in what astronomers call contact binaries. Others keep their distance, separated by hundreds of times the Earth-Sun gap, tracing slow, graceful orbits over thousands of years. These differences matter enormously for any planets nearby. In some systems, planets orbit just one star, largely ignoring the other. In others, planets circle both stars together in wide loops known as circumbinary orbits. Either arrangement could, under the right conditions, support long-term planetary stability. A plausible 2-sun Earth. To imagine Earth with 2 suns without destroying it outright, scientists consider relatively gentle setups. One plausible scenario places a second star about 80% the mass of our Sun at a distance comparable to Saturn's orbit. That may sound extreme, but observations of real exoplanet systems suggest such arrangements can remain stable for billions of years. In this case, Earth could still orbit our primary Sun much as it does today, while the second star adds an extra, steady source of light and heat rather than chaos. Seasons would change, but not explode. Contrary to popular imagination, 2 suns would not necessarily roast the planet or plunge it into wild temperature swings. Instead, Earth's seasons might become more nuanced. When both suns appeared on the same side of the sky, their combined energy would gently raise global temperatures, perhaps making summers slightly warmer and longer. When they were positioned opposite each other, their effects would partially balance out, leading to milder transitions. Rather than violent extremes, the planet would experience layered seasonal rhythms shaped by orbital geometry. Days, nights, and the rhythm of light. Earth's rotation would remain largely intact, meaning we would still have regular days and nights. However, twilight would behave differently. Some nights might never grow fully dark, washed in the faint glow of the second sun lingering near the horizon. Shadows would multiply, overlap, and shift direction across the day. Timekeeping would become more complex but not unpredictable. The sky would follow patterns, just richer and more intricate ones than we know today. Tides and gravity. Despite the presence of an extra star, Earth's tides would still be dominated by the moon. Because the hypothetical second sun is so distant, its gravitational pull on Earth would be relatively weak compared to our lunar companion. The result would be subtle variations rather than catastrophic tidal surges. Oceans would rise and fall in familiar ways, with only slight additional cycles layered on top. Detectable to scientists, perhaps, but not world-ending. Plants under a double light source. Life would feel the impact of 2 suns most strongly in how it captures energy. Plants in particular would evolve new strategies for photosynthesis. Some species might track both suns across the sky, adjusting leaf angles and pigments throughout the day. Others could specialize, thriving during periods when one sun dominates while going dormant during the other's peak. Forests might display shifting colors depending on which star is overhead, turning landscapes into living light sensors. Animals of the double shadow. Animals too would adapt in remarkable ways. Vision systems could become more complex, capable of processing overlapping light sources and constantly shifting shadows. Some species might develop eyes tuned to slightly different wavelengths, optimizing vision under varied lighting conditions. Nocturnal animals would time their activity not simply around night, but around periods when both suns are absent from the sky. A rarer and more precious darkness than we experience now. How humans might have evolved. Under two suns, human evolution itself could diverge dramatically. Researchers speculate that our eyes might adapt to perceive a broader range of light, possibly extending into near-infrared wavelengths, much like some animals on Earth already do. This would fundamentally alter how we perceive the world. Colors we consider invisible today could become part of everyday experience, reshaping art, communication, and even emotional expression. A head start in astronomy. Civilization under a binary sky would grow up immersed in orbital mechanics. Early observers would have two moving suns to track, offering an immediate lesson in gravity and motion. Ancient astronomers might discover complex celestial patterns far earlier than we did, simply because the sky itself would demand explanation. Calendars would be more intricate, agricultural planning more precise, and seasonal forecasting more sophisticated from the very beginning. Farming, food, and time. Agriculture would adapt to the dual sun cycle as well. Farmers might plant different crops to exploit specific lighting periods, using the predictable interplay of the two stars to maximize yields. Harvest festivals could be tied not just to seasons but to alignments of the suns themselves. Timekeeping, already central to human organization, would evolve with greater precision, embedding astronomy deeply into daily life. Myths, gods, and meaning. Perhaps the most profound changes would be cultural. Nearly every ancient civilization on Earth worshipped the sun in some form. With two suns, mythology would double in richness. Would they be portrayed as siblings, rivals, lovers, or eternal partners? Stories, art, and religious rituals would revolve around their interactions. Architecture might align temples with rare dual sunrises, and literature would draw endless metaphors from their cosmic dance. Science and spaceflight in a binary world. As science advanced, living in a two-sun system could provide unexpected advantages. Gravitational interactions would be visible and measurable in everyday astronomy, making abstract concepts tangible. Space exploration would require more complex calculations, but it would not be impossible. In fact, growing up with two gravitational anchors might push engineers and physicists toward deeper understanding earlier in history. Searching the universe with new eyes. Humanity's search for life beyond Earth might also take a different direction. Instead of focusing mainly on single-star systems, astronomers from a binary Earth could be more open to the idea that habitable worlds thrive under multiple suns. Techniques for detecting planets in such systems might develop sooner, widening our cosmic perspective long before modern telescopes ever existed. A familiar world made strange. In the end, a two-sun Earth would not be an unrecognizable nightmare. Oceans would still lap against shores, forests would still grow, and civilizations would still rise and fall. Yet everything, from biology to belief systems, would be shaped by a sky that never quite behaves the same way twice. Our single-sun world feels simple only because we are used to it. In a galaxy full of stellar partnerships, simplicity is the exception, not the rule. Somewhere out there, beneath a sky lit by two suns, intelligent beings may be watching double sunsets and wondering the same question we ask now. What would life be like with only one? If you enjoyed exploring how life, evolution, and civilization could unfold under the light of two suns, make sure you like and subscribe. We dive into science, space, and mind-bending scenarios that change how you see the universe, and there's a lot more waiting beyond the horizon.